Hi everyone, this is Professor H. Rahman from Agricultural and Food Engineering Department. I welcome you all to this traction engineering course. This is lecture 40 where I will try to give a tutorial on how to compute slip angle, understeer coefficient and verify the slide slope stability of a tractor while moving across a slope. So, the concepts will be a computation of lateral force and slip angles developed by a tractor. Then we will be finding out understeer coefficient to decide the steering condition, whether it is understeer, oversteer or neutral steer. Then we will try to verify the stability of the tractor while moving across a slopy land. So, I will discuss three problems. The first problem is a 6/16 tractor tire has a cornering stiffness of 133.30 kilonewton per radian and a camber stiffness of 229 Newton per radian. The camber angle at which the tire is fitted to the axle is 4 degree. If both the cornering force and camber thrust are acting in the same direction and they are linearly related to slip and camber angle respectively, then determine the total lateral force developed for a slip angle of 3 degree. So, what we have to do in this problem is we have been given the data related to cornering stiffness of front that is tire 6/16 and the camber stiffness. So, we know that total force which is developed, side force developed is dependent on the side lateral force due to slip angle S alpha plus lateral force due to camber angle F S gamma. So, Fs alpha and Fs gamma I have put a plus sign because I have indicated that they are acting in the same direction. So, that is why I have put a positive sign. If I have indicated that they are acting in opposite direction, then obviously I have to put a minus sign depending on their directions. Now, what is given is they are linearly related. Obviously, the slip angle is 3 degree and the camber angle is 4 degree. So, obviously, at a smaller angle we know that the side force is linearly related to the cornering stiffness. So, what we can write is F S alpha will be equal to cornering stiffness C S alpha into alpha, but here alpha will be in radians. Okay. So, CSF is given as 133.3, this is in kilonewton, into alpha is given as slip angle is given as 3 degree. So, 3 into pi by 180. So, this will be in kilonewton. Now, similarly, for finding out the side force due to camber angle, we have to take the camber stiffness. So, F S gamma, which is the side force or the lateral force developed due to camber angle. So, I can write as cornering stiffness camber stiffness C S gamma into beta gamma. So, now C S gamma which is given as 229, this is Newton, and gamma is given as 4 degree. So, 4 into pi by 180. So, what we will get is in Newton, what we have got here is in kilonewton. So, change the units, then add it, that will give you the total lateral force which is developed by a 6/16 tractor tire with the given data. So, basically you have to see that what is the relationship, since it has been given that it is linearly related. So, it becomes easier for you to calculate the lateral force. And the second thing which has to be seen is whether the directions of this lateral force, that is due to slip angle, and the lateral force which is developed due to camber angle, whether they are in the same direction or they are in the opposite direction. So, that has to be seen, then only you can easily calculate what is the total lateral force. The next problem is related to the steering. A two-wheel drive tractor which has a total weight of 18.2 kilonewton. It has a wheelbase 1.85 meter with a static weight distribution of 30% at the front axle and 70% at the rear axle. The cornering stiffness of each of the front tire is given and that of the rear tire is given. So, what you are been asked to find out is draw conclusions for the slip angle of front and rear tires. Okay. So, what you have to find out is first the understeer coefficient. For finding out the understeer coefficient, what you have to do is KUS is nothing but weight coming on the front wheel divided by C, the cornering stiffness C alpha F minus W R by C alpha R. So, now in this data which are given, we have to find out these values, then only we can compute KUS. So, what data is given? Cornering stiffness is given for the front tire and the rear tire. So, these values are given. So, C alpha F is given as 38.92 and C alpha R is given as 36.25 and WF and WR we have to find out. So, how to find out? WF is the weight coming on each of the wheel. So, the axle weight, now we have given the distribution with a total weight. So, the front axle is going to experience a weight which will be equal to 0.3 into 18.2. So, the front wheel will be experiencing a weight which will be equal to this divided by 2. So, that will give you WF. Similarly, for the rear axle 0.7 into 18.2 and the rear wheel will experience a weight which will be equal to this divided by 2, assuming that the weight is equally distributed among the two rear wheels and the weight is distributed equally distributed among the front rear wheels. So, that will give you WR. So, you know C alpha F, you know WF, you know C alpha R, you know WR. So, if you substitute in this equation, that will give you a value. So, if the value is positive, that means this is a understeer condition. If value is negative, this is a oversteer condition. If it is and if the value is 0, then it is neutral steer. So, we have to draw conclusion about slip angles. So, slip angles is nothing but alpha. So, alpha is nothing but F by CSF, lateral force by CSF. So, that means what is the lateral force developed by CSF. So, first we have to find out KUS. Once you know the KUS value, then we will find out whether it is a neutral steer, understeer or oversteer. Now, if it is neutral steer, the turning radius, the other component which I asked is turning radius is constant. If it is understeer, the turning radius will be decreasing, and if it is oversteer, that means when the KUS value is negative, it is oversteering, that means the turning radius is increasing. So, that is the conclusion you have to find out. Now, he is asking that determine the speed above which the tractor will exhibit directional instability. So, when we find out KUS, that will indicate whether you are in understeer or oversteer condition. If it is you are in understeer condition, then you have to calculate the B characteristic speed, which is nothing but in this case what we observed is we are getting a KUS value which is negative, that means it is an oversteering condition. So, oversteering condition means we have to find out the critical speed. So, critical speed V critical will be equal to square root of G into L by minus K U S. So, since K U S you got a negative value, so when you substitute here you will find out the velocity some value. So, roughly around it is coming 13.1 meter per second. So, that means this is the critical speed beyond which if we exceed then there will be a directional instability. Suppose the data which are given that will lead you to a value of KUS positive. So, what will happen? If it is a positive value, that means the turning radius is decreasing. So, you have to calculate B characteristics, which is nothing but GL upon QS. Okay. So, that will give you a value which will indicate the limit beyond which if you exceed, that is going to give you directional instability. I hope I have clarified. Then the third problem will be related to the side slope stability. A tractor fitted with 616 tire in the front axle and 13.628 tire in the rear axle. This has a and it has a total weight of 2400 kg with a weight distribution of 35% and 65% at the front and rear axles respectively. The track width 1.2 meter and its CG is at a height of 0.8 meter from ground, and this tractor is moving across a slopy land which is 20 degree with the horizontal. The front tire has a cornering stiffness, camber stiffness. The rear tire has a cornering stiffness of this much. The camber angle at which the tire is fitted to the front axle is given. If both the cornering force and camber thrust are acting in the same direction and they are linearly related to slip and camber angles, with a slip angle of 4 degree for the front tires and 3 degree for the rear tires, verify whether the tractor is stable during operation against overturning and sliding. So, for overturning we have to find out tan beta value. So, tan beta is nothing but 20 degree, beta is given as 20 degree. Now, you have to find out T upon 2S, that is track width by 2 into height of CG from the ground. If tan beta value is greater than this, then there is a possibility of overturning. So, in our condition track width is given as 1.2 by 2 into height of CG is given as 0.8. So, this will give you roughly around 0.3. So, if you take tan inverse of this value, this will give around 36 degree, whereas tan beta will give you a value around 0.36 and this value is around 0.5 something. So, that means tan beta is lesser than this expression. So, the vehicle is stable, it is not going to overturn. So, this is one condition. The second condition is we have to verify the stability against sliding. We have verified that the vehicle is stable against overturning. Now, for sliding we know that when there is a vehicle or tractor is moving, CG is here. So, it will have a component W sin beta, and this is lateral force which is developed at the rear wheels. Similarly, lateral force will be developed at the front wheels. Now, W sin beta has to be supported by this lateral force. So, now the second component we have to find out what is the total lateral force acting on the tractor or the vehicle. So, to find out total, there will be 2 front wheels, there will be 2 rear wheels, assuming that each of the front wheels will be developing the same lateral force. So, for the front wheel, we have to calculate lateral force for the front wheel. We have to calculate lateral force due to slip angle. We have this has to be added with lateral force due to camber angle, and they are linearly related. The thrust is linearly related. So, the cornering stiffness is given, cornering stiffness is 133.30 into the slip angle is given as 4 degree for the front tires. So, 4 into pi by 180 plus 229. So, this has to be, if you have to find out with Newton, they have to convert it to Newton. This is 133 is in kilonewton. So, 229 into camber angle is given as 4 degree, 4 into pi by 180. This is the lateral force which is developed at the front wheel. This has to be multiplied with 2 to find out the total lateral force developed by the front wheels. Similarly, you have to find out the lateral force which is developed at the rear wheel. Since there is no camber angle in case of a tractor at the rear wheels, so we are only considering lateral force due to slip angle only. So, it is given rear wheels cornering stiffness is given as 90. So, 90 into 1000, and the slip angle is given as 3 degree for the rear tire. So, 3 into pi by 180. So, this has to be multiplied with 2 to find out the total lateral force developed by the 2 rear wheels. Now, since total lateral force you have to find out for the tractor. So, that will be summation of this force plus this force. So, that will be equal to at least equal to W sin beta. W is given as 2400 into 9.81, that becomes Newton, into sin beta, sine of 20 degree. So, this should be equal to at least, then only the vehicle is not going to slide. If it is higher than these two summations, then the vehicle is going to overturn. If it is lesser than these two, then the vehicle is stable. So, let me repeat this one. The first case is we have to find out regarding the overturning. For overturning, we have to find out tan beta value, and tan beta value should be greater than T by 2h. Okay. So, this condition has to be satisfied. If tan beta is less than this value, then there is no overturning. Now, the second condition of instability is your sliding. So, that will come, this W sin beta component should be lesser than the side force which is developed by the tractor. Since the tractor has 4 tires and we assume that each of the front wheel will develop the same lateral force and each of the rear wheels will be developing the same lateral force. So, we try to find out what is the lateral force developed by the front, each of the front wheel. So, since front wheel has both slip angle and camber angle, so you have to find out lateral force due to slip angle and we have to find out lateral force due to camber angle. And since the cornering stiffness and the camber stiffness are given, So, by multiplying this, we can find out what is the total lateral force acting on each of the wheel. Then we multiply with the 2 to find out what is the total force from the front wheels. And in case of rear wheel, since there is no camber, so only we will calculate the lateral force which is developed due to slip, and we follow the same procedure because the slip angle is given and the cornering stiffness for rear tires are given. So, whatever value is obtained, that has to be multiplied with 2, and the summation of these two forces should be greater than this W sin beta, then only there will be no sliding, otherwise there will be sliding. So, in brief, I have discussed how to calculate lateral force, then how to calculate the steering characteristics, that means whether this wheel is whether the vehicle is understeer, oversteer or neutral steer, and basically this is calculated taking into consideration the understeer coefficient, which is a function of weight distribution and is a function of the cornering stiffness. Then we try to calculate the side slope stability for two conditions. One is your overturning, the other one is sliding. I hope these three problems is they are going to help you in understanding these concepts of oversteering, understeering, side slope stability. Thank you. You can refer to Theory of Ground Vehicles by Wong J.Y.